Hello. Okay, I just want to go over a couple things with momentum and impulse that are near the back of your book. So if you can pull out your booklet and go to page 28 and take out your calculator too, that would be handy. Okay. Any object that is moving has momentum. Hopefully by now you watched the Bill Nye video, which goes through it pretty clearly. And in order to bring the object to a stop or a rest, we must change its momentum to 0. Right on, right? The units for momentum are interesting. They are kilograms, meters per second, and then the direction it goes. Okay? And the dot just means multiplied. Okay? So this means that momentum is a vector quantity, which means that it has direction. Okay, so far so good. Okay, now think about it. What makes an object difficult to bring to a stop? What do you think? Right on. The more mass it has, when it's moving, the more momentum. Okay, so would you rather collide with a train moving at 2 meters per second or a mosquito moving at the same speed? And why do you think so? Me, personally, I would prefer the mosquito. And why? It has less mass while moving, so it has less momentum. Okay? Now, from the train and mosquito example, we know that the mass of a train makes it more difficult to stop than a mosquito moving at the same speed. So objects that are moving fast are also hard to stop. Bullets have a very small mass, but it can be extremely difficult to stop. One, because of its velocity. See? So here you can see the two variables that contribute to momentum. Okay? If a moving object has more mass, it has more momentum. Also, if an object has more velocity, it also has more momentum. If either mass or velocity or both of an object increases, okay, the object will be more difficult to bring to a stop. Okay? So if that mosquito gained 10 pounds and turned into a bird, and that bird gained, I'm trying to think of what else it can turn into that flies, but you get it. The more mass it has, the more velocity it has, the more momentum it has. Okay, turn the page. Okay, so here are two examples. Okay, so the first one says, suppose we have a car and a truck driving side by side at the same velocity. So let's say they're both going at 80 kilometers per hour. Okay, which one has the greater mass? Right on, the truck. And which one will take longer to stop? Also the truck. And why? Okay, because more mass while moving equals more momentum. Right on. Second example, suppose we have two identical cars driving at different speeds. So let's call this vehicle A and this vehicle B. And maybe this one's going at 10 kilometers per hour and this one's going at 50 kilometers per hour. Okay, which one will take longer to stop? right? B, right? Y, more velocity equals more momentum. Awesome. I think you get the picture. Okay, so take a look at the next page that says calculating momentum. Don't get overwhelmed by that table because we are not going to fill that in. But what I want you to get from this is the equation. Okay, so the momentum of an object, or the quantity or amount of its motion, is related to its mass and velocity and can be calculated by, let's try a different color. Momentum, come on. Okay, here we go. Momentum equals, oh for goodness sakes, mass times velocity. Okay, and in symbols, momentum is P with an arrow over top, mass is capital M, and then velocity is V with the arrow over top. Okay, because these are both vector quantities. Awesome. Okay, so that's the equation that we're working with. Okay, let's turn the page. Flip it over. Impulse. I'm pretty sure he talked about this in the Bill Nye video as well. So if we want to stop a moving object, we must change its momentum to 0. Okay, and in order to do this, we must apply an impulse, which is a force applied over a period of time. Okay, and impulse can be calculated by, impulse can be calculated by force times a change in time. Or the equation is I equals F times, and remember change in was delta and time is T. So a change in time multiplied by the force gives us the impulse. If you want to apply a greater impulse, you must apply more force or apply the force for a longer period of time. Okay, so what we're saying is that if we increase the time it takes to reach 0, we decrease the force. Okay, so what type of a relationship is this? This is an inverse relationship. Okay, so either we're going to experience a greater force because it happens over a small period of time, or we're going to experience a small force because it happens over a greater period of time. That's kind of my visual to help me remember. Okay, so let's take a look at the math just a little bit closer here. Okay, we know already that force equals mass times acceleration from Newton's second law, right? Okay, but we also know that acceleration is a change in our velocity, right? So force also equals mass times a change in our velocity over our change in time. So if we want to get rid of this denominator, let's multiply both sides by change in time. That means we get to cancel time out on the right-hand side. Okay, so now what are we left with? We have F times delta t equals m times change in velocity. Okay, and what does this mean here? Well, look at that. Impulse. So an impulse is a change in momentum. Okay, we just did a little science proof, okay? So that's all it's saying, is that impulse is a change in momentum. So think about if we go bungee jumping, okay? What is wrapped around your ankles before you jump off of the bridge or the high plateau, right? Is it a chain? No, it's like a soft cord, right? Because if we used a chain, when we hit the bottom of the chain or the end of the chain, we would experience a very large force over a small period of time, right? That would not be very fun. But if we have the soft cord, okay, we're going to experience a small force over a long period of time, because that cord is going to stretch and let us bounce so that we slow down over a longer period of time, okay? Same thing with an egg toss, right? If we were in class, we would be chucking eggs back and forth, I promise, and raw ones too, not baked ones. But if you're catching the egg, most of you are going to take the hand and then kind of cup it, right? And this is so that we increase the time it takes for the egg to slow down so it experiences a small force, okay? Same thing when you're catching a baseball, right? If you were to just hold your hand still, the ball comes into your hand and you don't move at all, you're going to experience a big force over a small period of time. But if instead you kind of retract your hand or your arm, you're going to experience a smaller force over a greater time. Okay, I hope that makes sense. Turn the page. The last thing I want to show you is just a couple calculations and how to calculate momentum and impulse. Okay, so what I've done at the top here is I took the equation for momentum. So these should have vectors over top, and this should be capital M. I'll just fix that here. Okay, so all I've done is rearrange the equation so that each one has the variable by itself. Okay, it doesn't really matter if you do that or not, you can just change it later. So let's take a look at here. Sam is having a snowball fight with his friend. If he throws the snowball with a momentum of 8.2 kilograms meters per second and a velocity of 4.1 meters per second, what is the mass of the snowball? Okay, so we want the mass, so I'm going to use the middle equation here. Okay, so M equals momentum divided by velocity. Okay, so the first thing I do is I write down my equation. Next thing I do is I plug in my information. I'm given the momentum. That's 8.2 kilograms, and it's supposed to have a dot there, meters per second, and we're going forward. And my velocity is 4.1 meters per second. And we're going to assume we're always going forwards unless we know something different. Okay, so I can right away cancel the same things that are in the numerator and in the denominator. And what am I left with for my mass? Okay, my mass equals 2 kilograms. Okay, so the mass of the snowball is 2 kilograms. Right on. Let's try one more. Try number 6. Okay, a person runs a race at a speed of 1.3 meters per second. If they have a mass of 59 kilograms, what is the person's momentum? Okay, so first thing, momentum equals mass times velocity. Okay, plug in what I know. Momentum equals 59 kilograms times 1.3 meters per second, and we'll assume it's going forward. So I'm going to multiply those two things together, and 59 times 1.3 gives me 76.7, and then I literally can just bring these units down. Kilograms, dot, meters per second, going forward. Okay, right on. So that's how you calculate momentum. Turn the page. Impulse is very similar. Again, I have the equation at the top, and then I've just rearranged it so you have one that shows impulse, which you're finding, one that shows force, and one that shows time. Okay, so if we take a look at the first one, it says a baseball pitcher throws a fastball with 1,000 with an impulse with 100 Newton second impulse. If he applied the force in 0.15 seconds, how much force did he apply? Okay, so I'm going to use this middle equation. Force equals impulse divided by time. Plug in what I need, or what I have. Force equals, and those are the units for impulse. So 100 Ns, which is literally the units for force and the units for time to multiply together, divided by 0.15 seconds. Can cancel out what is the same. Oh, and look what I'm left with. 100 divided by 0.15 is 666.7 newtons. Excellent. That's it. Okay, I'll take you through one more. A hockey puck is hit by a hockey player at the goalie. The puck is hit with 1,200 newtons of force, and the stick made contact for just under a second. Well, what was the impulse? Impulse equals force times time. Impulse equals 1,200 newtons times 0.1 seconds. Impulse equals 120 Ns. And that's it. That's all I got. Okay. So I hope now you'll go and try the Cushioning the Blow article and watching Understanding Car Crashes. It's basic physics. Have a great day.